All right, so we left off with plugging in 2, which is on the right side of our graph right here. All right, and then when we plug in 2 into this function, we get -2. So that's going to be a point right here. All right. Any other point except the endpoints, you could draw open or close or whatever. It doesn't really matter. You're just trying to see like a feel for what type of slope this certain graph has. All right. So this is gonna look like that. All right. You don't have to be an artist. All right, because I'm definitely not. So that's our first part of the graph. Okay. And then the next part, this actually should be if x is less than or equal to 1, right? So it's going to be 2x minus 1 if x is less than or equal to 1, all right? So in this case, we have 2x minus 1 if x is less than or equal to 1. If we plug that in, our endpoint at 1, we're going to get 2 times 1. That's a bad looking 2, and that made it even worse. Let me just erase it so we can get another chance. 2 times 1 minus 1, which is equal to 1. All right. So at the point 1, we get 1 again. All right. So this open circle now becomes a closed circle because at the point 1, this part of the function gives us 1, and it's also included in our domain. We know that because we have an equal sign under the inequality. And whenever that happens, whenever we have an equal sign, that means that that specific point or that specific x coordinate corresponds to a y coordinate that is included in our domain. All right? So then we know that now. And then we plug in points that are to the left of the x-axis because it says if x is less than or equal to 1. So let's plug in 0. So if we plug in 0, we're going to get 2 times 0 minus 1, which is equal to -1. All right, so at 0, that's equal to -1. All right, and then we can make the graph look something like that. Again, it's just a rough sketch. We don't really need to be all artsy over here. All right. So then our part A says find the domain. All right. So the domain corresponds to all the x values in which this piecewise function undertakes. All right. So if we're looking from -infinity to our point 1, we see that this graph, since it goes on forever to the left side, is going to touch every single possible x value you could think of, all right, all the way up to infinity. And on the right side of 1, it's going to be the same exact story, all right? So that means that our final domain should be all real numbers or from -infinity to +infinity. All right? And that is our domain. Now to find our intercepts, we see that for our graph, we're only going to get one y-intercept, which is going to be this graph right here. And this graph corresponds to 2x minus 1 if x is greater than or equal to 1. Right? And how do we find y-intercepts? We find y-intercepts by plugging in 0 for our x's, right? So if we plug in 0 into that function, we get 2 times 0 minus 1, which is equal to -1. Sorry for the little parentheses there. Right? So our y-intercept, y-int, is at 0, -1. All right? But we see on the graph that we have 2 x-intercepts, right? One for the 2x minus 1 graph and one for the -3x plus 4 graph, all right? So then we have to do it for both of them. And how do we find our intercept, our x-intercepts in this case? We set y equal to 0. So we have 3x plus 4 equal to 0. And I'm just going to do it over here. 2x minus 1 is equal to 0, right? So we get -3x is equal to -4. And then x is equal to 4/3. Then we get 2x is equal to 1. And then x is equal to 1/2. All right, so our x-intercepts are 4/3, 0, 1/2, 0. All right, and that's the end of that question. All right, main thing to remember is to try to graph the function first. All right, because when you graph the function, everything becomes apparent. All the y-intercepts, the x-intercepts, even the domain, as you saw, was apparent because we saw that every single x value in this case is going to be touched by the graph. All right, so that was our first question. Now let's move on to the next one. If anybody doesn't have any questions, all right, moving on. So for this one, it says, for the quadratic function 3x squared plus 6x plus 1, determine whether it opens up or down, find its vertex, axis of symmetry, and y and x intercepts, if any. All right, so does it open up or down? Open up or down? To figure that out, we have to see the sign in front of our a constant in our parabola, all right? Because if the sign is positive, then our parabola opens up, and if it's negative, then our parabola opens down. In this case, we have f of x is equal to 3x squared plus 6x plus 1, right? There's a positive 3 in front of our x squared, so that means this parabola opens up. All right, now find its vertex. To find its vertex, our first step is to find our axis of symmetry, which is conveniently our next question. So our axis of symmetry is just going to be x is equal to -b over 2a, right? Let's just write it down over here, our equation once again. A is equal to 3, b is equal to 6, and c is equal to 1. So if we know this equation, we just plug in all our values. So b is -6. This should be a b. That made it worse. So that's a b, not a 6, but this is a 6. Over 2 times a, and a is 3, which is equal to -1, and that's our axis of symmetry, or our x-coordinate of our vertex, right? So then, to find the y-coordinate of our vertex, we just plug in this x-coordinate back into the equation, so we get 3 times negative 1 squared plus 6 times negative 1 plus 1, and that's equal to 3 minus 6 plus 1 is equal to negative 3 plus 1, which is equal to negative 2. So then finally, our vertex is negative 1, comma negative 2. All right? And then just to summarize again, axis of symmetry is going to be what we first found when we were trying to find the vertex, which was that x is equal to negative 1. All right, so then our y and x intercepts, okay, remember y-intercept. To find that is to set all our x's equal to 0 and finding what our y is equal to. So we have that f of x is equal to 3x squared plus 6x plus 1. And to find our y-intercept, this actually becomes f of 0, right? Because we're plugging in a 0 for every x, which is equal to 3 times 0 squared plus 6 times 0 plus 1. And that's ultimately equal to 1, right? And then for our x-intercept, it's the opposite. We set our y equal to 0 and solve for our x's. And in this case, it's going to be 0 is equal to 3x squared plus 6x plus 1, right? And what do we do now? We have to, yes, factor. All right. So if we don't really want to factor and just kind of do it a simpler way, we could just use our handy formula, negative b plus or minus the square root of b squared minus 4ac over 2a. All right? That's equal to negative 6 plus or minus the square root of 6 squared minus 4 times a, which is 3, times c, which is 1, all over 2 times 3. Right? Simplify that even further. We get negative 6 plus or minus square root of 36 minus 12 over 6 is equal to negative 6 plus or minus square root of 24 over 6. All right, simplify that as much as you can. Negative 6 plus or minus. All right, inside the 24, we have the square root of 4 times 6, right? All over 6. Let's just continue that over here. So we could do this separately, right? Take out the square root of 4, which is 2. So then we have negative 6 plus or minus 2 times the square root of 6 all over 6. And then finally, take out a 2 from that negative 6, that 2, and that 6. And then we get the negative 3 plus or minus square root of 6 over 3, right? Trying to factor that from just seeing this would be almost impossible, but if you did it, then good for you. You're extremely smart, because this handy formula right here is going to save you from time wasting, especially on your test when there's a bunch of questions and you're all nervous and stuff like that. All right, so we have two x-intercepts of negative 3 plus or minus square root of 6. Right? We can even simplify that even further to have negative 1 plus or minus the square root of 6 over 3. And then finally, didn't finish that over there, sorry. And then finally, our x-intercepts are -1 minus square root of 6 over 3, oops, comma 0, comma -1 plus square root of 6 over 3. Oop, did that mistake one more time. Comma 0. All right. So that's that for that question. All right. Now let's move on to the next one. We have the month revenue are achieved by selling X wristwatches if figured to be R of X is equal to 79X minus 0.2X squared. The monthly cost C of selling X wristwatches is C of X is equal to 32X plus 1600. How many wristwatches must be sold to maximize revenue? And what is the maximum revenue? Right? Whenever you see a maximum question, they want, or minimizing question for that matter, they want you to find the vertex of the equation that you have, right? In this case, they're specifying that they want to maximize revenue, right? And revenue is 79x minus 0.2x squared, right? So then, if all we have to do is find the vertex, we know how to do it, right? But our first step, it says how many wristwatches must be sold to maximize revenue. This basically just says to find the axis of symmetry, or just find our x coordinate of our vertex, which is equal to -b over 2a, right? And let's just rewrite the revenue function over here. R of x is equal to 79x minus 0.2x squared, right? If we wanted to put it in standard form, we have -0.2x squared plus 79x. -0.2 is our A, and 79 is our B. All right? So if we know that, we have all the components needed to find the axis of symmetry, which is equal to -79 over 2 times -0.2, and that's going to be equal to 197.5. Right? So that's our axis of symmetry, and it says what is the maximum revenue. In this case, our maximum revenue is just the x value when we plug in 197.5 into the revenue. So we have R of 197.5, because we're plugging in 197.5 into every x, is equal to 79 times 197.5 minus 0.2 times 197.5 squared. And I'll leave you guys to do that calculation because you guys have calculators on your test, so this calculation shouldn't be too bad, right? We're just really focused on what the concept is and what exactly we need to do to find what the answer to this question is, right? So once you find that, you have the answer to what is the maximum revenue. Okay? Second question. Profit is given by P of X is equal to R of X minus C of X, right? So the question is just to find what the profit function is. So we have P of X is equal to R of X minus C of X, which is equal to, plugging in all the formulas, we have 79x minus 0.2x squared minus parentheses, don't forget that parenthesis, those parentheses, not that parenthesis, minus 32x plus 1600. All right. And we have to simplify that further. So we do 79x minus 32x. That's going to give us 47x. We still have that minus 0.2x squared out in the front. And then we have a minus 1600. All right. So now we have the profit function right here, in which we could just rewrite it so it could be in a standard parabolic form. And that's negative 0.2x squared plus 47x minus 1600. Right? And then finally, part C. The question asks, how many wristwatches must be sold to maximize profit? It says here on part A, how many wristwatches must be sold to maximize your revenue? And we found the axis of symmetry for that to answer that question. So it's going to be the same exact process of finding the axis of symmetry for this particular equation now to find how many wristwatches must be sold to maximize profit. All right. So then we have that x is equal to negative b over 2a. And we know that b is 47, and we know that a is negative 0.2, so we just plug that in. 47 over negative 2 times negative 0.2. And if I do that quickly on the calculator, that's going to be 47 over 0.4, which is equal to 117.5. And that is our axis of symmetry, or our x part, x coordinate of our vertex, right? So then the next step of this question is, what is the maximum profit? And that's the same exact thing that we did for part A, of plugging in whatever our x coordinate was, or whatever our axis of symmetry was, into the particular equation at hand. In this case, it's going to be profit, and just finding what that equals to. So if we do that, we're going to have P of 117.5 is equal to negative 0.2 times 117.5 squared plus 47 times 117.5 minus 1600, right? And ultimately, this will give you an answer, but once again, I'll leave you to that calculation yourself, because you guys have calculators on your test, and it shouldn't be too bad of a problem to do after that, after the concept, right? So that's that. We have everything we needed to answer these questions, right? It's basically just finding the vertex, right? And yeah, we can move on to the next question if nobody has any questions, concerns. No. Oh, no. Okay, good. Thank you for your input. Got a little quiet there, but all right. So next question. Oh, Anya is typing. We have I'm just going to move on for just a second. We have that Diana has available 800 available yards of fencing and wishes to enclose a rectangular area. All right. Our first question is, express the area A of the rectangle. Wait, do you always have to round up to the nearest integer, or only when it says to do so? I don't really know how your test wants it, but I mean, if it rounds up to the nearest integer, in this case, the 197.5 is just going to turn into 198, and this one is going to turn into 118. But I'm not really sure what exactly your test entails, so that's just up to the directions of the test. It might actually want you to round up just because the answers are going to be nicer and they're going to be whole numbers instead of like decimals and stuff like that. But I'm not too sure about that, right? But you guys know how to round up to the nearest integer, so you guys should be fine either way. All right, so next question. We have that Diana has 800 available yards of fencing and wishes to enclose a rectangular area. Express the area A of the rectangle as a function of the width W of the rectangle. Sorry for the typos here, but it's math. We don't really care about grammar. So, first, for these types of questions, let's draw what exactly is happening. We have a rectangle. Oops. Of length L, and width W, and width W, right? And this whole perimeter is equal to, it says it in the question, 800 yards, right? So we know what a perimeter of a rectangle is, right? We know the equation. So all we have to do is find that equation, right? So we have W plus W, that's just equal to 2W. L plus L, that's just equal to 2L. And that's all equal to 800, right? Make it easier on yourself. Divide everything through by 2. Oops, undo that. Divide everything by 2, which will give you W plus L, which is equal to 400. Right? That's not the last step for this part though, because it says express the area A of the rectangle as a function of the width, right? So we know what an area of a rectangle is. It's just length times width, right? So that's A is equal to length times width. Oops, I'm just drawing X. Length times width, right? So let's solve the perimeter equation in terms of W. So we have that L is equal to 400 minus W for the perimeter. And then the next step is plugging in what our perimeter is into our equation for area to get A is equal to 400 minus W times W, which ultimately is 400W minus W squared. And there you have it. We expressed A, or area A of the rectangle, as a function of the width W of the rectangle, all right? Expressing something as a function of a certain variable just means that we have the variable inside of the equation like that, all right? So we have this in terms that we know, right? That W squared makes that a parabola, right? And what direction does it open? Oh, does it open up or does it open down? In this case, it has a negative in front of the A term right here. So that means this parabola opens down. All right. So we got through that. Now we're doing part B. It says, for what value of W is the area largest? For what value of W is the area largest? Wait a minute. Didn't we do something similar in the past question? It says how many wristwatches must be sold to maximize revenue? And this one says for what value of area of W is the area largest? Those are two of the same questions. So we're going to do the same exact thing for both of them. All right, and what was the thing that we did for the last question? We just found the axis of symmetry, right? So let's rearrange that area as A is equal to negative W squared plus 400 W, right? So then to find the axis of symmetry, we have that X is equal to negative B. Our B is 400 and our A is negative 1. So we have negative 400 over 2 times negative 1. And that's going to be equal to 200. And that's our answer for what value of W is the area largest. Right? Not too bad. Part C is what is the maximum area, and once again it's just like the second part of these questions. What is the maximum revenue? What is the maximum area? All we did was plug in that axis of symmetry back into the corresponding function, right? So if we do that, we're just going to have A is equal to negative 200 squared plus 400 times 200. 200 squared is 40,000. It's negative in front, so it's negative 40,000 plus 400 times 200. That's 80,000. So this ultimately is 40,000 whatever. Oh, they gave it to us. Yards squared. Right? Whatever units they give should be expressed in this term right here. Right? So not too bad of a question. It's just finding the axis of symmetry, basically. Or in the first part, actually, let's just go through it once more. We found the perimeter equation. We solved it in terms of W. We know what an area of a rectangle is, so then we just plug in the variable L back into the equation, and we have area now in terms of W, right? Part B, we have an area equation, and we want to find the axis of symmetry, so we rearrange it, right? To know what A and B is, just in a simpler case, and then find what our X is, or axis of symmetry, and then we plug that in to our formula for part C to get what maximum area could be, right? So I'm going to skip the next question just because it's something you guys have done before. And I'm just going to do this one because I feel like the students have been having troubles on this. But yeah. So suppose that f of x is equal to 7x minus 6 and g of x is equal to negative 4x plus 5. Find f of x is equal to 0. All we have to do for this question, all we have to do, it says that f of x is equal to 0. So that means the left-hand side of this equation should just be equal to 0. So we have that 0 is equal to 7x minus 6, and then solve for x. That in turn results in 7x is equal to 6, and then x is equal to 6 over 7. All right. Part B is solve f of x is greater than 0. So we have f of x is equal to 7x minus 6. Right? And then we create the inequality 7x minus 6 greater than 0. And then we solve for x again. But this time it's an inequality, remember? So it's going to be kind of like a domain or interval type answer. So we have 7x is greater than 6, which in turn makes it, oh, why did that 7 go away? Okay, x is greater than 6 over 7, right? So then we have the answer, x is greater than 6 over 7, but we have to write that in interval notation, right? Some of you guys are kind of confused about interval notation. So interval notation just means that we want to cover the entire domain that this inequality is stating. So it says that x is greater than 6 over 7, so we start at 6 over 7 in our interval, not included, remember, because it doesn't have an equal sign under it. Why is that 6 going away? Okay. Comma, if x can be any greater number than 6 over 7, then that takes care of every single other number up to infinity. All right? Oh my, why are things getting erased? Okay. And that is that. All right, that's part B. So let's move on to part C. We have that f of x is equal to g of x, and we want to solve for that. Okay, so what do? We just make these two equations equal to each other and then solve for x. So we have that 7x minus 6 is equal to negative 4x plus 5, right? Then solve for x. So we add 4x on this side to get 11x is equal to, we add 6 on the other side to get 11x is equal to 11, and then beautifully, because math is beautiful, divide 11 on both sides to get that x is equal to 1. All right? Did I make a mistake? Hopefully not. Can you explain when to use the union thing in interval notation, please? All right, so union notation. Right, so, let's see. Let's say we have two different, I'm just going to hop on this inequality right here. We have that x is greater than 6 over 7, right? And we also have that, let's say x is less than, let's say 0, right? So we have that x is greater than 6 over 7 and x is less than 0. So let's take care of this guy first because it's including smaller numbers. So it's x is less than 0, so that's from all the way from negative infinity to 0. Not included because remember, once again, it doesn't have the equal sign on it. Under it, sorry. All right? But then from 0, it jumps to the inequality that x is greater than 6 over 7. Right? So then we use a union sign to indicate that jump from one endpoint to another. So then this becomes 6 over 7 to infinity. I don't know why these 6's keep on disappearing, but bear with me here. 6 over 7 to infinity. Alright? Because that takes care of every x number all the way up to infinity, since x has or can be greater than 6 over 7. Alright? So whenever you use an interval union sign in interval notation, it's to mark a separation between two different endpoints. In this case, it's 0 and 6 over 7. Right? Right? It's usually found when you have like two different inequalities like that, when you're comparing two different things in a certain inequality or something like that. All right? This union sign is just to connect these two intervals from negative infinity to 0 and 6 over 7 to infinity. They could be the same number? Yeah, they could be the same number. For example, if you have an example, that'd be actually really nice. If you mean like infinity to 0, union 0 to infinity, that's kind of iffy, because negative infinity, so let's write it down. It has negative infinity to 0, union 0 to infinity. Okay, yeah, Nicholas, yeah, exactly. Like if there's a discontinuity, I think you guys learned about discontinuities, right? If there's a discontinuity at x is equal to 0, then that 0 is not going to be inside the interval, right? So that's exactly right, what you did there. That 0 is not going to be included in the interval, so we use a union sign to connect, like I said, to connect the two intervals from negative infinity to 0 and 0 to infinity, right? One other thing that could be a discontinuity was that if there was a vertical asymptote at x is equal to 0, this exact answer would be your domain, all right? So that's that. Thank you for the question, though. Hopefully I answered all of them, but yeah, let's move on now. So yeah, suppose the quantity supplied S and quantity demanded D of t-shirts at a concert are given by the following functions, where P is the price. S of P is equal to negative 350 plus 40p, and D of P is equal to 1150 minus 60p, right? And I was going to come up with the question that we want to find the equilibrium price, right? So to find that equilibrium price, first part of that word equilibrium, equal, so we set both of these equal to each other. So that looks like S of P is equal to D of P. That's going to be equal to negative 350 plus 40p is equal to 1150 minus 60p. Why did that 0 go away, but none of the other zeros went away? I do not know technology, but we can just move on. So all we have to do is solve for p, right? So subtract negative 40 on that side, or add 60 on this side. Let's actually do that. So we add 60 on this side to get 100p is equal to, add 350 on the other side to get 1500, and then divide 100 on both sides to get that p is equal to 150. Right? Now the next question I wanted to come up with was find the quantity supplied and quantity demanded at equilibrium. All right? So let me write that down. Part A was find the equilibrium price, and part B, find quantity supplied. Oops, I can't spell. Find quantity supplied and demanded at equilibrium price. All right? So then all you have to do for this, sorry, wow, my handwriting is pretty bad today. That's an E. Hopefully you guys understood that. But all we have to do for this is we already found the equilibrium price. To find the quantity supplied and quantity demanded, all we have to do is plug in that into both of these equations. So we get S of 150 is equal to negative 350 plus 40 times 150. That's equal to negative 350 plus 6,000. And that's equal to, I think, 5,650. All right. Next one is D of P. That's equal to, oops. We already know what to do, right? We just plug in 150. So D of 150 is equal to 1150 minus 60 times 150. Right? This was supposed to be, oops, sorry about that, yeah. This is supposed to be a plus, and this is supposed to be a minus, like the other question. Right, so this is supposed to be a plus, and this is supposed to be a minus. So then all we have to do is simplify that. 1150 plus 60 times 150, I think, is 9,000. That's a negative 1150. So that adds up to 7,850 if my math is correct, hopefully. All right, so that's our quantity supplied, which is 5,650, and our quantity demanded at equilibrium price. All right, so then next question. This one's pretty easy. It's 8 already. That's fine. We just had 3 more questions, and they're not too bad. A truck rental company rents a moving truck for 1 day by charging 23 plus 0.12 per mile. Write a linear equation that relates the cost C in dollars of renting the truck to the number X of miles driven. What is the cost of renting the truck if the truck is driven 146 miles? All right, this one's not too bad at all. So they want a linear equation to find the cost C in dollars of renting the truck to the number of miles driven. All right, so they give us all the information needed. So let's write it. We have C of X, which is our cost. That's equal to, it says a truck rental company rents a moving truck for 1 day by charging $23. All right, so we move that right there. 23 plus 0.12 per mile. And that's just going to be plus 0.12 times X. All right, because it's per mile, and we want this equation in terms of number X of miles driven, right? So keep the variables constant. right? So that's our linear equation. Then the second part, let me undo that because I kind of crossed out 23. So the second part of the question is, what is the cost of renting the truck if the truck is driven 146 miles? And all you have to do is plug in 146 miles to X. And we got it. 23 plus 0.12 times 146. Use our handy calculators here, which you will be using on the test as well. That's equal to 23 plus 17.52. Ugly decimal, but we will strive through it. 23 plus 17.52 is just 40.52, right? And then that's our final answer. 40.52 is the amount of dollars it would cost for renting the truck if the truck is driven 146 miles. Okay. So that's it for that one. Let's move on to second to last one, the penultimate question. I know you guys are excited. So we have a linear function is given by h of x is equal to negative 4x plus 6. Find the slope and y-intercept and graph the function. This is kind of just review, right? What's the slope of a linear function? It's whatever m is equal to, right? And what is the form of a linear function? Y is equal to mx plus b, right? In this case, our m is just whatever is in front, or any case for that matter for a linear function, is whatever is in front of our x. In this case, it's negative 4. So the slope is equal to negative 4. All right, y-intercept, remember guys, we did this already. We set our x equal to 0, and we get h of 0 is equal to negative 4 times 0 plus 6, which is equal to 6. And that is our y-intercept. Y equals 6. If we want to graph that. Boom, boom, boom. That's probably going to delete itself. Oh, wow. It did it. Okay. And then it says, determine whether the function is increasing, decreasing, or constant. Guys, we know this. If a function is increasing, the slope should be positive. If it's decreasing, it should be negative. And if it's constant, that means that it has a slope of 0. So what was our slope? Negative 4, right? It's a negative, so it's decreasing. Boom, boom, boom. Not too bad of a question. Hopefully you get all 20 or however many questions you have on the test like this, or quiz. Right? So last question. Wow. Finally. It says the function f is defined as follows. F of x is equal to 2x if x does not equal 0, and 1 if x is equal to 0. Alright, so let's graph this. 2x if x is not equal to 0. So if x can't be equal to 0, we can't even put a point or anything like that for this 2x right here. So we have, let's say if we plug in 1, it's going to be 2 times 1, which is just equal to 2. So that's 2. Alright? And then it's going to look like that. Going to keep on going like that. Keep on going, keep on going, keep on going. But it's not even going to touch it. Don't touch it. Don't touch x equals 0. Because it is not included in that side of the piecewise function. All right? And then our next part is 1 if x is equal to 0. So at x is equal to 0, this graph is equal to 1. All right? Find the domain and any intercepts of, and then graph the function. We already graphed it. The domain is already seen here, right? It's the x values from the left come from negative infinity all the way to 0, but 0 is still included in the domain. Don't forget, because of this part of the piecewise function. It is included in the domain. So then we say that from negative infinity to, and on the right side of 0, it goes all the way to positive infinity, right? So then we go all the way to positive infinity as well for the domain. And then we're good, we're solid, and we are golden. So our any intercepts, does the graph have any intercepts? What is an x-intercept when y is equal to 0, right? When y is equal to 0, is there a point on this graph where it touches that? No. So there is no y-intercept for this graph. But what is an x-intercept? When a function is equal to 0, right? So when a function is equal to 0, oops, I got this mixed up. A y-intercept is when x is equal to 0. So when x is equal to 0, we got a value of 1. It should be right here. I don't know why that was there. At 2. Right? Hopefully this, I don't have to do this too many times. Please keep it. Please. Oh my god. One more time. It's gonna work. Come on. Oh my god. I'm gonna keep on doing it. Oh my. Why? Just why? Alright. This is getting annoying now. Okay, just think of it as there being a point at 1 right there, right? So y-intercept is whenever x is equal to 0, and at x equal to 0, there's a y at 1. So there is a y-intercept of 0, 1. But are there any x-intercepts? That's when y is equal to 0, right? When y is equal to 0, does this graph even touch the x-axis? No, right? So that means there are no or none, no x-intercepts for this piecewise function, right? Renzo, you're typing a question right now, I think. Why doesn't it go through the x? Because of this right here. It says 2x if x cannot be equal to 0, right? So then 2x is this line going, but x cannot be equal to 0. So we skip 0 right here and then jump after to keep on graphing 2x all the way up to infinity. All right. So that's basically the end of this review. If you guys have any questions, Type it. If we are asked to plot that, how will we know where to place the dot? What do you mean the dot? Like the one, this part right here, 1 if x is equal to 0? Well, the thing, it should be right here. Hopefully you're seeing this because it's probably going to get deleted in a second. Yep, it got deleted again. But yeah, it should be right here because at x equals 0, it's going to give us a y value of 1. All right. I mean the beginning of the two lines. So the beginning of the two lines, so like around here, you say? Like where I'm showing the arrows? Or around here? Because if it's around here, there you shouldn't have to put any dots. Maybe you... No, by 0, yeah, just as close as possible. Yeah, just as close as possible, exactly. Just as close as possible that it can't touch 0. Or in this case, it's the origin. So don't touch the origin, but try to get as close as possible. I don't know how picky they are on the quizzes or tests that you guys have. So yeah. All right. So yeah, that marks the end of this review session.